Okay, welcome to the video number 6, my dear students. Before going to the discussing that is circular polarized light or elliptical polarized light, first I'll give some conditions. How to identify the different polarized lights. Different means one is what? Unpolarized light. And another one is what? Plain polarized light. Next is partially polarized light, circularly polarized light, elliptically polarized light. Different lights. How to identify even whether the given light is of what kind? By using the what? Nicol prism. Before going to this, just I'm discussing some two examples I'm discussing. This is the unpolarized light. This is the unpolarized light. This unpolarized light passes through the Nicol prism, rotating Nicol prism. Here I'm not coming to the actual topic. But before discussing this idea is what? Required. This is the what? Nicol prism. It is called as an what? Analyzer. Analyzer. This prism is what? Rotated. Now if you observe through this, it is what? It is you are observing. Here, no variation in intensity. No variation in intensity of light. Remember that. No variation in intensity of light. If there is no variation in intensity of light, it must be what? Unpolarized light. It is an unpolarized light. This is first one. Here is an observer. Here is an observer. Observer is here. Whenever the unpolarized light is allowed to pass through the rotating Nicol prism, the outcoming wave now, here there is no intensity of light. If there is no intensity of light, then one should conclude the incoming wave it should be an unpolarized light. Somewhat create a confusion. Please remember this point. Next case. Here the incident wave is a circularly polarized light. Circularly polarized light. Circularly polarized light. I am observing through the rotating Nicol prism. This light I am observing through the rotating Nicol prism. It is also analyzer. And this is what? Rotating. Here also observation is you are observing here. This observer here. No variation in intensity of light. Intensity of light. Both cases. Here you see. The outcoming result is same, but it's very difficult to judge whether this incoming light is it unpolarized light or circularly polarized light and all that. First remember this. Is it? I think it is clear for you that is. Whenever the unpolarized light and also circularly polarized light, when it is allowed to pass through the rotating Nicol prism here, the outcoming case is what? No variation in intensity of light. Here also no variation in intensity of light. Remember this point. Next. Now I will go for the production. I will go this. Now I will come to your actual topic. Production. You should write in the examination only this much. Production. In the production, you see, sorry. Now, this is the incident wave, plain polarized light. In polarized light. I'll come to this point. This is the quarter wave plate. This is the quarter wave plate. Quarter wave plate. As a result, here outcoming wave is circularly polarized. circularly polarized. This is what circularly polarized. Circularly polarized light. Here you see, here the plane polarized light, no doubt. Here the plane of vibrations, it makes an angle theta equal to 45 degree with respect to optic axis. This point is important. How to produce the? Whenever the plane polarized light, okay, with this plane of vibrations, listen carefully, plane of vibrations makes an angle theta equal to 45 degree with respect to what? Optic axis. When such kind of light is allowed to incident to the quarter wave plate, here circularly polarized light is obtained. Why circularly polarized light obtained is, we know that in the previous video now that in case of quarter wave plate here, the phase difference equal to difference equal to what? Pi by 2. The phase difference is created between the which wave here? One is O ray and another one is what? E ray. Here it is 90 degree, you make it off, that it becomes what? 45 degree. And also in case of circular polarized light, the amplitude of O ray and amplitude of E ray both are what? Same here. Amplitudes are same. Amplitude of O ray and E ray are what? Same here. In the third video, I discussed one equation, that is x square by a square plus y square by b square, something formula is there, no? There you can recall it. Here, how to write? Simple, that is how to produce. Whenever the plane polarized light with its plane of vibrations makes an angle of how much it is? 45 degree with respect to optic axis. When it is allowed to incident on the quarter wave plate, what happens? Circularly polarized light is obtained. Then, now I want to check it, whether this is circularly polarized light or not. How to check it? Here, you put a one Nicol prism, you put it. You go on, rotate the Nicol prism here. By rotating the Nicol prism, then what happens? The intensity is varies. There is no change in intensity. There is no change in what? Intensity of light and all that. There also I discussed two cases. There no change in intensity is observed in two cases. One is unpolarized light and also what? Circularly polarized light. But here what happens? No change in intensity is observed. It is difficult to judge whether is it unpolarized light or circularly polarized light and all that. For that, I am going for the reverse mechanism. I am going now. I think you understood this. From the point of examination, you write only this much. Whenever the plane polarized light and its plane of vibrations what? Makes an angle theta equal to what? 45 degree with respect to optic axis. When it is allowed to incident to the quarter wave plate, what happens? Circularly polarized light is obtained. Because where the phase difference between the coil created between the ordinary and extraordinary is how much it is? 90 degree. And the amplitude of the ordinary and extraordinary are what? Same here. That's why circularly polarized light is obtained. Right? This much. Next is deduction, that is deduction. Now, how to detect? When this light, okay, what I'm doing is, this is the circularly polarized light. This is the quarter wave plate. Quarter. That is circularly polarized light. This is quarter wave plate. Now reverse, that is the outcoming wave is plane polarized light. This is the plane polarized light. Here, this plane polarized light I am observing through the what? Nicol prism, that is. It is a Nicol prism. It is called as a analyzer, and this is what rotated. When the Nicol prism is rotated, here you are observing this outcoming light. Here the observation is intensity of the light, intensity of the light, intensity of the light varies from maximum to minimum equal to 0. This is the condition. If the intensity varies from maximum to equal to 0, then you should say that this is the what? Circularly polarized light here. This is the reverse mechanism. Okay. Now the production is over and detection is also what? Over. This point is very, very important, my students. This is important. Here, once I tell you the circular polarized light, again you are passing through the what? Quarter wave plane. Then what kind of light is obtained here? Plane polarized light. This plane polarized light is allowed to pass through the what? A rotating Nicol prism. It acts like a what? Analyzer. If the observer observes that if the intensity varies from maximum to minimum equal to 0, then this should be what? Circularly polarized light. This is about the production and detection. It carries normally 4 marks it carries here. For 8 mark question here, they will ask you for the circularly, and another one is what? Elliptically polarized light. Okay, students, now I am discussing the production and detection of elliptically polarized light. First, I will discuss the production. Here also it is a plane polarized light. This is also plane polarized light. Polarized light. This is quarter wave plate. This is elliptically polarized light is produced. Elliptically polarized light. Here the question arises in your mind. In previous case also you used the plane polarized light. Here also you are using the what? Plane polarized light. In previous case, by passing the plane polarized light through the quarter wave plate, circularly polarized light is obtained. But here, elliptically polarized light is obtained. How it differs, how it is possible. But one thing you remember, this plane polarized light is that no, the plane of vibrations, theta should not be equal to 0 degree. Theta should not be equal to what? 45 degree. And theta should not be equal to what? 90 degree. This is the situation. And also the amplitude of ordinary wave and extraordinary wave should not be equal. A is not equal to what? B here. A is the amplitude of one ordinary wave and B is the amplitude of the what? Extraordinary wave. Both amplitude should be what? Different. Then only it is possible. Because in the circle, what happens? This axis, you see, the radius is, amplitude is what? Same. But in the ellipse, you know that this is semi-major axis and this is what? Minor axis. This is called as semi-major axis and this is what? Semi-minor axis. This A and B, they are not at all what? Equal here. This is how elliptically polarized light is produced here. So you see, once I will explain. Whenever the plane polarized light is there now, with this plane of vibrations, with respect to optic axis, should not be equal to 0 degree, should not be equal to 45 degree, and should not be equal to what? 90 degree. Other than this, it may incident at any angle. It may be 30 degree, 60 degree, what it may be, no problem. And also, amplitude of both ordinary wave and extraordinary wave should be different. When it is allowed to incident on the quarter wave plate here, elliptically polarized light is obtained. This is regarding the production, that is. Next is detection, that is. Now I want to confirm it, whether the outcoming light is what? Elliptically polarized light or not. I want to confirm it. How to confirm? This is detection I am getting. Now, detection. Now, next is detection. I'm going reverse phenomena or detection. This is the elliptically polarized light. This is the elliptically polarized light. This light I will pass through the quarter wave plate. I'm passing through the quarter wave plate. Like this. Then suddenly you're supposed to get what? You're supposed to get plane polarized light. It is what? Reverse mechanism. This is the reverse mechanism. Like this. Here, again the plane of vibrations is there now. The plane of vibrations, theta is not equal to 0 degree, theta is not equal to 45 degree, and theta is not equal to what? 90 degree. This is what? Elliptically polarized light. Polarized light. This is what? Quarter wave. Here, next is whatever the light is there now, just I'm observing through the what Nicol prism, that is. I'm observing through the Nicol prism. And this Nicol prism, I will call it as a what? Analyzer. It is rotated, that is. It is rotated. Here, that is what? Observer is here, that is. Here, your inference, observation should be such that here, intensity of the light, here, intensity of the light varies from intensity of the light, here, conclusion, important. If intensity of light, here, what you're observing here, intensity of light varies from maximum to minimum, which is not equal to what? 0. Which is not equal to 0. Then this confirms, then if this condition is satisfied, it confirms what? Confirms the elliptically polarized light. Elliptically polarized light. Elliptically polarized light. If write this much, definitely will get 8 marks. Nothing in this, students. But this condition, don't forget, theta is not equal to 0 degree, theta is not equal to 45 degree, and theta is not equal to what? 90 degree. And also, the amplitudes of ordinary wave and extraordinary wave are also not same. This completes your what? The production and detection of the plane polarized light, circularly polarized light, and also what? Elliptically polarized light. And next is what? Optical activity is there, and one more equation is there, that is okay. If I do those two things here, it completes your syllabus. Thank you. Bye and all.